Hi guys, I'm Patra. In this session, we strive to understand the basic concepts of scalars, vectors, and matrices. A scalar is described by a magnitude alone. A vector is described by both magnitude and direction. In this diagram, we can see that this vector has the magnitude and a direction. A scalar can be represented by an integer data type. This S is a scalar for us. A vector can be represented by a list of numbers. So this A is vector. So how do you add two vectors? A is a vector, B is a vector. We can transform this B to here. In this way, we are preserving its magnitude as well as its direction. This green vector is a resultant vector. In Python, we can create a function that accepts two lists. Zip is used to iterate over multiple lists. So for every iteration, we are adding its corresponding numbers. In scalar multiplication, we multiply a scalar to a vector. Here A is a vector, 2 is a scalar. So when we multiply, we are not changing the direction of the vector, we are just changing its magnitude. So we can create a function that accepts one vector and a scalar, and for every item in the vector we're multiplying it by s. Dot product of two vectors is the sum of the products of the corresponding entries. Length of those vectors has to be same. This can be generalized in this equation. It is the summation of I equals to 1 to n ai bi, where n is the number of items in the list. We can create a function that accepts two lists. So for every iteration, we're multiplying its corresponding entries. A matrix is a rectangular array of numbers arranged in rows and columns. Below is a matrix with dimension 2 cross 3. So we have two rows and three columns. In our case, we can think of it as a two-dimensional list of numbers. Aij represents ith row and jth column. So if you want to know A1, 2, that means the first row and the second column, this 14. Matrix multiplication is very important for machine learning. So when you're going to multiply two matrix, number of columns in the first matrix has to be same as the number of rows in the second matrix. Here we have three columns in the first matrix and three rows in the second matrix. So now we can multiply. We're going to apply dot product to the first row of the first matrix and first column of the second matrix, and that result is going to be first row and first column of our resultant matrix. Likewise, we can apply dot product to the first row of the first matrix and second column of the second matrix, that is going to be first row and second column of our resultant matrix. This is the generalization of our matrix multiplication. So when we're going to apply dot product to the first row of the first column, sorry, first matrix, and second column of the second matrix, that is going to be first row and second column of our resultant matrix. One thing you need to remember, the dimension of the resultant matrix is going to be the number of rows in the first matrix and number of columns in the second matrix. And we have four rows in the first matrix and three columns in the second matrix. That's why it is 4 cross 3. And we can create a function to do this operation But in a real application, we don't do that because it is a complicated affair. There is a library called NumPy. We can import it, and it has a function matmul, and that accepts to matrix, and that will do the job for us. Matrix has a huge applications in web, like CSS3 and Canvas uses matrix to keep track of all the states. This is all about basics of linear algebra. Next session is on probability. Thanks for watching.